Hello, in this video I'm going to talk about operator overloading. So operator overloading is sometimes necessary if you want to redefine things like the equals operator or the plus operator or the not operator. And just like we can overload functions, we can overload operators in C#, and we can do that in Java and C++ as well. So there's some basic rules for operator overloading in C#. Overloaded operators are implemented as public static functions. And like, why are they static? Well, imagine you were comparing two null references. Well, then there's no instance created, right? So we can't have them be instance methods, so we have to make them static methods. And the return type for this public static function is going to be dependent on context. So if you're adding two integers together, you're going to return an integer. If you're adding two complex numbers together, you're going to return a complex number. If you're comparing two things, you're going to return a Boolean, true or false. So the return type is context dependent. And then instead of the function name, you have the keyword operator followed by the actual operator that you're trying to overload. And then finally you have your parameters, and the number of parameters depends on what type of operator you're overloading. If it's a unary operator, like the not operator, that just takes one parameter. If it's a binary operator, like it's adding something or comparing things, well, that takes two operands. So then you're going to have two parameters into your overloaded operator. So imagine that we have a class called complex, and complex represents a complex number, and it has two parts, a real part and an imaginary part. And this is the classic overloaded operator example that you've probably seen in other languages. So what would it look like in C# to overload the plus operator so we could add these two complex numbers together? So let's look at our rules, right? We said that an operator was going to be a public static method, and then the return type here is going to be a complex number, because that just makes sense. If we add two complex numbers, the result will be a complex number. If we were adding two integers or something, two large integers, then we'd get a large integer back, right? So this is dependent on context, and in this case it makes sense to return a complex number. And then finally, instead of a function name, we have the keyword operator followed by the actual operator, and then we have our parameters. And since when we add two things, we have two parameters. So that's how it works. Now let's think about if we add two integers, a or C and B, to make a variable called a. C and B would not be changed in the process of adding them together. So what we're going to do inside of our public static function is create a temporary object and return that. So the operators shouldn't, in the case of addition, shouldn't modify the operands. So here's what it would look like in C# code. So here's our public static function. There's our return type, followed by the keyword operator, and then the operator we're overloading, and here's our two parameters. And what we can do is make a new complex number here, and then set the temporary object's real part equal to the sum of the real parts. We can set the temporary object's imaginary part to the sum of the imaginary parts, and then return that. So we're creating a temporary object and returning it, but we're not modifying the original the parameters at all, right? And that just makes sense. So there it is. That's how you'd overload the plus operator for a complex number. Okay, what about the equals function? What if we wanted to compare the two complex numbers? Well, the equals as a function like this is not really an operator. We can't overload it, but we can override it certainly, because it's virtual. And but there's some interesting stuff here about this equals operator. This is built into this equals function is built into every object in C#. And the thing that you're comparing it to it's defined as an object. And this kind of poses an interesting problem, is that you could compare any object to any other object. You could test to see if an integer equals a string, because strings and integers are all objects, and we don't know what this thing on the right is. So this is a good example of when you might want to check the specific class type of an object. So normally if you're using the is and as operators to determine if something is a particular instance of a class or to cast it to a particular type of class and see if that cast is valid. You're probably using polymorphism wrong, and you should redesign your object hierarchy. But this is one of those cases where it actually makes sense to test an object's specific type. And the reason we want to do that is if we're comparing two things and they're different types, then they can't possibly be equal. An integer can't possibly be equal to a string. That just doesn't make sense. So in an overloaded equals operator, or an overloaded equals function, an overridden equals function, what you want to first do is test the type of the object that is the parameter. So let's look at an example of that. So here's an overridden equals function. So the function's got to be public, otherwise we can't call it. We're overriding the equals function in the base class, and this equals returns true, and then it takes an object O as a parameter. And then what we want to do is we want to test to see, is O actually an instance of a complex object class? And if it is, then we can compare the real parts and the imaginary parts. We can test each subpart for equality and return that. However, if the class types don't even match, then this comparison doesn't even make sense, and we just want to automatically return false. So this is what you're going to see inside of an overridden equals function. You're going to see the first thing that you're going to do is test to see, is this thing that I'm being compared to, is it even the right type of object? And if it's not, return false. Then, but if the types do match, then you can make some sort of meaningful comparison. Like maybe you're comparing car objects, and maybe you want to compare the VIN numbers. If the VIN numbers are the same, then the objects are equal. What about the overloaded equals operator? What if we wanted to compare or test for equality using the double equal instead of the equals function? Well, once we have overridden our equals function, we can actually use that to overload the equal operator. And we've already learned the rules for that, right? It's going to be a public static function. The return type will be bool, because when you test for equality, you're saying yes or no, it's equal or it's not equal, followed by operator, double equal sign, and then it's a binary operator, so it's going to take two parameters. So we're going to get something like this. It's a public static function, and it returns bool, operator, double equals, and there are two parameters. So we're going to compare two complex numbers. And then all we can do here is, all we need to do is just use our equal sign. We can say, is the first thing equal to the second thing? Now, the C# compiler will tell you, if you just did this, it would say, hey, if you overload the double equals operator, you have to overload the not equals operator. And that's very easy to do. Just copy and paste this and return the opposite. You know, put a not sign right there, and you're fine. You're good to go. So there you go. Once you know how to do these, they're easy to crank out. So they're going to be public static methods. The return type is context dependent. Instead of a function name, you have the word operator followed by the actual operator, and then one or two parameters. So that's it. That's all you need to do to overload operators, and that should get you going in the homework. So I know in one of the homeworks there's, I think it's chapter 12, they ask you to do the complex numbers. Now you should have a better handle on how to do that. You've even got some source code to operate off of. So there you go. That's all you need to know about complex numbers and operator overloading. But if you have any questions on that, feel free to email me or ask me.